device used to move air by imparting both kinetic and potential energy to air. Potential energy is the static pressure and kinetic energy is the velocity pressure. It works on the centrifugal effect principle. First we will see the basic components of a centrifugal fan. A centrifugal fan consists of inlet flange, inlet cone, impeller, casing, shaft cover, shaft, bearing, belt, pulley, belt cover, motor, and outlet flange. Now we will see the working of centrifugal fan. Here a 4-pole motor with an RPM of 1750 will serve power to the fan. As the electricity is passed to the motor, it starts rotating. The smaller driver pulley keyed to the motor shaft starts rotating. Power is transmitted through belt to the bigger driven pulley. The shaft keyed to the bigger pulley starts rotating. In the belt and pulley power transmission system, belts are used to transmit power from one shaft to another by means of pulleys, which rotates at the same speed, or at different speeds. Here belt and pulley power transmission is used to rotate impeller at a lower speed than the motor. To make impeller speed less than the motor speed, the driven pulley should be bigger than the driver pulley. Bearings are connected to the shaft. Bearings will allow the rotational motion, and it supports both axial and radial fan loads. Another end of the shaft is fixed on impeller, which allows a power transmission. As a result, impeller rotates at the speed of the driven pulley. As the impeller starts rotating, air enters the fan axially, and it will be displaced radially. Impeller will displace the air at the inlet, and making a negative pressure region at inlet. And pressure energy is imparted to air, which in turn makes the outlet region a positive pressure region. So air will be moved from high pressure region to low pressure region. Inlet is low pressure region, so air enters through inlet. As the outlet is a positive pressure region, the air will be displaced through the outlet. Now we will see the working principle of centrifugal fans. In centrifugal fan, the operating principle is a combination of two effects: centrifugal effect and deflection of airflow by the blades. Centrifugal force is the apparent outward force on a mass when it is rotated. Here the air enter inside impeller experience the centrifugal effect, and it will be pushed outwards. If we look closer, we can see that first the air is being pushed outwards, and then it's deflected by the impellers. Then air moves in a spiral direction. Both the effects will increase its static pressure and velocity pressure. When the air reaches to the casing, air gets slowed down little, which increases the static pressure by the expense of the reduced velocity pressure. This is Venturi inlet. It improves the fan performance by improving the airflow pattern. Venturi inlet will reduce the air turbulence at the inlet, and it will reduces the pressure losses. This is inlet guard. It will provide protection from accidental contact with the spinning blades of a fan. It also prevents foreign objects from entering to the fan, and helps to protect the inner components from damage. Now we will see the types of centrifugal impellers. Centrifugal impellers are categorized according to its blade shape. Most common types are backward curved impeller, backward inclined impeller, forward curved impeller, and radial impeller. In backward curved impellers, blade is curved opposite to the rotation of impeller. It's used for high pressure and high flow applications. It's the most efficient out of the four impellers mentioned here. Backward inclined impellers are almost same as a backward curved impellers. The difference is blade is not curved. It is inclined opposite to the rotation of impeller. It's used for contaminant air applications. It's little less efficient than backward curved impellers. Forward curved impellers. As the name indicates, blade is curved forward in the direction of impeller rotation. It is less efficient when compared to backward impellers. It is mainly used for high flow and clean air applications. Radial blade impellers. Its blades are neither curved nor inclined to any direction of impeller rotation. It's used for high pressure and contaminant air application. It's the least efficient amongst the 4 impellers mentioned here. Thank you for watching.